and I'm going to walk through the answers for these. For number 1, you needed to evaluate g of 7, where g of x equals 5x squared minus 2. So you would put 7 in for x. I kind of went all over the place, but I put 7 in for x, figured out what 7 squared was, and then multiplied and then subtracted. So your answer would be g of 7 equals 243, or g of x equals 243. For number 2, you needed to graph that equation. So you first need to solve it, get it in slope-intercept form. So add 3x to both sides, rearrange it, and then divide everything by -2. And then once you have that equation, our y-intercept would be at -2, our slope would be at -3/2, so up 3, left 2 as many times as possible, or down 3, right 2 once. And that would be the graph of that line. Number 3, I don't know if this happened on you guys' paper, but my points were a little off for some of them, so I just made up decimals. The domain, I have -3, -1, 0, and 3. Reading left to right, least to greatest. The range for mine, they were a little off. If yours were spot on, whatever the points were, then that's fine. But for mine, I just chose random decimals, -3.5, -2.5, and then 2 and 3. Do we have any questions on those 3? And then for number 4 on the back, you also needed to find the domain and range. So I have them listed in set builder notation as well as interval notation. So set builder notation would be this first one from -5 to 4. Interval notation, you could use the square brackets because it's included from -5 to 4 for the domain. And then for the range, it'd be from -5 to 6, either way. For 5, this we may have not done this before, but I'm just going to quickly talk through it. So it's given 2 different equations, f of x equals x and g of x equals -1/2 x plus 2. And then we're comparing the 2. Really, we're looking at g of x and comparing it to f of x. So in order to compare these, you have to look at the slope for one and the y-intercept for the other. When it's talking about shifted, it's talking about the y-intercept. You're comparing this y-intercept to this y-intercept. This is 2, this is 0. So 2 is higher than 0, so you can say this is shifted up. And then for part B, the steeper or less steep is comparing the slopes. So if I'm looking at -1/2 and comparing it to a slope of 1, -1/2 is lower or less than 1. So this would be less steep. Do you have any questions, Bishop? Yeah. You guys should all have the new set of notes on your desk for inverse variation. We're going to start those. So go ahead and get those in front of you. If your phone is a distraction, I would put it face down. That way it doesn't distract you. A lot of what we talk about for inverse variation is going to be related to what we talked about in direct variation, but it's going to be like the opposite. So an inverse variation is a specific relationship in which there is a constant product. Remember in direct it was a ratio. And that product is y times x between all ordered pairs. So direct was a ratio y over x. Inverse is a product y times x. Inverse variation equations are written in the form y equals k over x. So direct was y equals kx. This is y equals k over x. Just like before, we could use this equation to find our value of k by getting k by itself. So to do that, I would need to multiply both sides by x. So that product helps us find our k value for inverse variation. So now when we look at our constant k, we need to multiply the two together and make sure they're the same for all of them. So for this one, 1 times 20 equals 20. 2 times 10 equals 20. And 4 times 5 equals 20. So because they each equal 20, I can say my constant k is in fact 20. And then I could write my equation, y equals 20 over x. Just like with direct variation, if the constant is not the same for all of them, that would not be a constant k, and it would not be an inverse variation. Before we do one more, does anyone have questions on how we set this up, how we found that equation? Jake?
So that would just be the answer?
Yeah, this would be your final answer, your equation. Right? Let's do one with the table. For number 3, again, we're trying to find our value of k, so we need to multiply them. Someone multiply 2.4 times negative 5, tell me what you get. Negative 12. Negative 3 times 4 is negative 12. Negative 2 times 6 is negative 12. And negative 1 times 12 is negative 12. These are all the same, so I can say that my constant k is negative 12. So my equation would be what?
Y equals negative 12.
Correct. Right. If you haven't already, I want you to do 2 and 4. I'll give you a couple minutes to do that, and then we'll come back and talk about it. For 2, y equals negative 28 over x. To me, our constant k was negative 28.
So we write the case here.
Yes. Especially if it says identify the constant, so yes. Find k, write that down, and then write the equation. For 4, what was your constant K? 6. And your equation?
Y equals equal.
6 over x. Right? The next part of this is graphing. We are not actually going to graph. I'm just going to show you what it would look like. So we're going to do this one example together, and then you can skip the next two. So for this, because we know that K is y times x, I'm going to write that up here. And they tell us our constant is 16. We're going to list all the different numbers that would multiply to get 16. What times what would give me 16?
1.
And 16. What are some others? 8 and 4. Right, so for these, we're going to make a table with these values. Doesn't really matter which one is which. Actually, let me fix this. The reason I put those numbers again is because if my x is 1 and my y is 16, that would be a point. But if I switch them, that would still equal 16, but that would be a different point. So I'm going to plot all of these points. So 1, 16, and these are counting by 2s.
Or
There's 2s in between them. So 1, 16 will be somewhere here. 2, 8, 4, 4, 8, 2. And 16, 1. So what happens is it kind of curves, and it's going to look something like this. When we found these numbers, we were just looking at positive numbers, but we could also look at negative ones as well. Because if I multiply two negatives together, I still get a positive 16. So I could do the same thing, but do negative 1 and negative 16, negative 2 and negative 8, negative 4 and negative 4, negative 8 and negative 2, and negative 16 and negative 1. And plot those points. And it's going to make that same kind of curve, but on the opposite side. So where your direct variation was a line that went through the origin, your inverse variation looks something like this. So anytime you see something that looks like this, automatically that's an inverse.
if they're all negative, wouldn't that mean it's positive?
The constant is positive, yes. So there are two other examples to graph if you so choose, but you will not need to graph for the quiz or the test. So that would be strictly if you want to. Moving forward, those of you moving on to Algebra 2, you will learn more about graphing, inverse, variations, or the actual name for it. I want to say that's what it's called. But we'll learn those in a later class. Anyone still need this? Moving on, skipping 5 and 6, going to this table, we're going to do 2 of these examples, and then I think that's all we'll have time for today. We'll see though. So just as for direct variation, there were 2 different ways to solve this. Same thing here. We have to think about how we can solve for k, and then the other methods, solving for k, using the equation and solving like that. So again, we have to remember our k is y equals x, y times x, sorry. So for this, if we wanted to set up kind of like the proportion, but it won't be a proportion, I can set this up as an equation. 12 times 14 equals negative 24 times y. And that would mean whatever my k is on one side should be the same on the other. I don't know what that is. $168. And then we could divide both sides by 24, negative 24. So y would be negative 7. If I go back and I double check this side, I already know what my constant k is here is 168 because I multiplied 12 and 14. If I multiply negative 24 by negative 7, I should get positive 168 as well. I do. So you could set it up as an equation and find the missing value that way. Or you could do it the second method. I'm going to do 10. Before we do 10, does anyone have questions on how we set that up, how we get that answer? Okay. So if we're doing it the other way for 10, we would still need to find our value for k using the numbers we know first. So 21 times negative 3. Negative 63. So that would be our k value. We could write our equation, y equals negative 63 over x. And then input our missing values. So negative 7 is y. And we're looking for x. How would we solve this? Say that one more time. Multiply what? By 7. Multiply what by 7? So if I did that, this would just double. Not double, but it would be positive 49. We are going to multiply, not by 7. By x. So if we multiply both sides by x, it gets rid of it on this side. So then we have negative 7x equals negative 63. Then we could divide by negative 7. So that x equals 9. If that's right. And then we could double check this. 9 times -7 does equal -63, so the K works. And -63 over 9 does equal -7.
Is there a way to get that? Oh, okay.
So you
Oh, okay.
We're going to stop there for today. You are welcome to keep going if you so choose. When we come back Tuesday, or if we have whatever day that is next, we'll do 2 more together, and then I'll let you do some on your own, and then we'll do applications of inverse.
Someone does a wonder.
Yeah, right.